Okay, now we're going to talk about solving quadratic systems. And what we need to remember is that a system of linear equations is the ordered pair that satisfies the equation in the system. Okay, so the system is, or the solution to the system is an ordered pair. It's that point or set of points that works for all of the different equations. And the same is true for the solution of a linear quadratic system. Any pair, any ordered pair that satisfies both equations in the system is a solution to the system. So what we're looking for is the point or points that are on both equations or both graphs. And so one way we can look at that is by looking at the graph. This is an example of where we have two solutions because the parabola and the line cross in two different places. Let's see if that makes a little right there. Okay, so these 2 points where they cross, those are the two solutions of that of that system. For this system, I have one solution. It's that one point where the parabola and the line meet. And for this last one, there's no solution because there's no point where the two graphs meet. So the solution is the point where both graphs or both equations are correct or work. So in example 1 down here, I have really big points so that you can see exactly where they cross. I have a parabola. I'm going to put my little arrows on the end of them because that makes me happy. The parabola and a straight line. One of those points is right here. That point, the ordered pair for that point is left and right 0 and up 3. So that's one solution. My second solution is this ordered pair, which is to the right 4 and down 5. And these are the two solutions to the system. And I have two of them because it crosses in two places. Okay, so you can tell by looking at the graph what the solutions are. You find those points and those are the solutions. So we're going to do this one by graphing. I'm going to start with the linear. And I can graph this linear. It's in the form of y equals mx plus b, so I don't need to do a chart. 2 is my slope, and b is my y-intercept. So if I go over to my y-intercept, that's up 1. My slope is 2, so that means its slope is rise over run, so that's up 2 and over 1 from that point. And I'll do a couple to connect. And let me see what I'm going to use for a straight edge here. I'm going to use the edge of my pencil box. So you can use anything for a straight edge. There we go. Okay, so that's my the graph of my line. And then I'm going to graph my parabola. This parabola is in standard form. To get the vertex, when we have a parabola in standard form, remember the x of our vertex is negative b over 2a. I don't have a b term here, so that's 0 over 2a. 0 over anything is 0. So the x of my vertex is 0. I'm going to plug that back into the equation to get the y for my vertex. That's 0 squared minus 2, which is negative 2. So my vertex is 0, negative 2. And I'm going to go ahead and graph that 0, negative 2. And then when I do my chart to graph my parabola, 0, negative 2 is my vertex, so it's in the middle. And I really need 2 points on either side of it, so I'm going to have negative 1 and negative 2 to the left of it, and positive 1 and positive 2 to the right of it. And then we plug these into the equation to get our y values. 1 squared is 1 minus 2 is negative 1. 2 squared is 4 minus 2 is a positive 2. And these are going to mirror on the other side. So I have negative 1, negative 1, positive 1, negative 1. And then I have over 2 and up 2. Whoops. I want a 1 and up 2. I need to go over 2 and up 2. And to the left 2 and up 2. And just because I see that this parabola is going to cut through here, and then it's also going to cut through on this side, I'm going to add 3 and see what the coordinate for 3 is. 3 squared is 9 minus 2 is 7. If I go over 3 and up 7, that's going to be that point where it cuts through. That just happened to work out there. That way we have precise points. So these 2 points, this one and this one are the solutions to the system. This one is at positive 3, 7. This one is at negative 1, negative 1. So my solutions are positive 3, 7. Now let me make that so it's easier to read. Don't you love my erasable pens? I just love them. 3, 7. And the other solution is negative 1, negative 1. Okay, so the 2 points on the graph where they meet is the solution to the system. So that's one way that we can do it, is by looking at the graphs. The other way that we can solve systems is by substitution. If you have y equal to a number, or to an equation, here I've got y equal to all of this, I can take that and substitute it in for y in the other equation. So if I rewrite this first equation, I have 3x equals y. I'm going to take all of this and put it in place of y, so that's x squared plus 18x plus 40. All I did was substitute that in for my y value, and then I have plus 4. Now everything here are x values, so I can solve for x. In order to solve for x, though, I'm going to have you to use one of my ways of solving quadratics. Since it's a quadratic, I need to combine like terms and move everything over and set it equal to 0. So we'll do that one step at a time. I'm going to combine like terms on the right side first. So I have x squared plus 18x plus 40. And actually I can combine 40 and 4, so that's plus 44. I'm going to subtract, I need to set it equal to 0, so I'm going to subtract 3x from both sides. And I have 0 equals x squared plus 15x plus 44. And now I've got to figure out how I'm going to solve this. I can't do square root because I have a b term. It's a trinomial, so I'm going to see if I can factor. My a term is 1, my b term is 15, and my c term is 44. So 1 times 44 is 44. My b term is 15, so I need factors of 44 that multiply to be 44 and add to be 15, and that's going to be 4 and 11. So that's how I'm going to split my middle. So I have x squared plus 4x plus 11x plus 44. And when we split the middle, we do that so that we can factor by grouping. So I'm going to group those into 2 sets of 2. I can take an x out of this first set. X times x gives me x squared. X times positive 4 gives me positive 4x. This is a plus, so I'm going to factor out a positive number out of this. I can take 11 out of both of those. 11 times x gives me 11x, and 11 times 4 gives me 44. I'm going to take this common factor and factor it out, so I have x plus 4, and what I have left for the other parentheses is x plus 11. Now that I've factored it, I can take each of these factors, because I'm going to use the zero product property, set each of these equal to 0. X plus 4 equals 0, and x plus 11 equals 0. Here I'll subtract 4 from both sides, and I have x equals negative 4. Here I'll subtract 11 from both sides, and I have x equals negative 11. And those are my 2 solutions for that problem. Now, I'm not done. That told me what my x values are. Each of these x values have to be plugged in to find the y value that goes with it, because remember, when we solve systems by substitution, what we're doing is getting 2 ordered pairs. So I have to plug each of these back into one of these equations. The linear equation is going to be the easiest one to plug into. So I'm going to use first 3 times, when x is negative 4, 3 times negative 4 equals y plus 4. 3 times negative 4 is negative 12. I'm trying to get y by itself. Subtract 4 from both sides. And y is negative 16. So this solution is when x is negative 4, my y is negative 16. That's a solution. This is solving for x, to find my x values, but each of these x values is going to have an ordered pair that goes with it. So now I'm going to take the negative 11 and plug it in. So when x is negative 11, and I plug it into my linear equation, I have 3 times negative 11 equals y plus 4. 3 times negative 11 is negative 33. Subtract 4 from both sides, and I get negative 37 equals y. So this ordered pair, when x is negative 11, my y is negative 37. These two ordered pairs are the solution to the entire system. Okay, these were my x values. Make sure each x value gets plugged in to get a y value that goes with it, and those, remember, your solutions to systems are always going to be ordered pairs. Okay, let's try another one with substitution. On this one, I have that y equals all of this, so I can take this value for y and plug it in for y in the other equation. So when I rewrite this, I've got 2x plus 2, that's substituted in for y, and I have that equals x plus 4 squared minus 5. Since this is a binomial squared, that's sort of like the completing the square, what that looks like. In order to get it into standard form, I need to multiply this out. When I do that, I've got x plus 4 times x plus 4. I FOIL this. This is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So this whole thing is x squared plus 8x plus 16. Don't forget, I still have this minus 5 that's part of this equation also. This is just multiplying out the binomial squared, and then after I get that all worked out, I'm also going to subtract the 5 from that. And don't forget, all along on this side I have 2x plus 2. I'm going to combine like terms here, and I get x squared plus 8x. 16 minus 5 is 11. Next step is to set it equal to 0. So I'm going to subtract 2x from both sides. I'm also subtracting 2 from both sides. I'm going to do them both at the same time here. This will give me, all of these will cancel out and be 0. I have x squared. 8x minus 2x is a plus 6x. 11 minus 2 is a 9. Now I'm going to see if I can factor. I've got a trinomial. I'm going to see if I can factor it. My a term is 1, my b is positive 6, and my c is 9. So a times c, 1 times 9 is 9. My b term is 6. Numbers that multiply to be 9 and add to be 6 would be 3. So if I split the middle here, I have x squared plus 3x plus 3x plus 9. This is a plus 9 here. Factor by grouping. I have x times x plus 3 here, and I have 3 times x plus 3 over here. When I factor this out, I get x plus 3 times x plus 3. These are the same thing. Set them equal to 0. So I really only have one answer. Subtract 3 from both sides. My x is negative 3. Remember, that's your x value. You still have to plug that in to find the corresponding y value. But if I only have one x value, that means I'm only going to have one ordered pair. So I only have to plug it in once. I'm going to plug it into the linear equation because that's generally easier. I have 2 times negative 3 plus 2 equals y. 2 times negative 3 is negative 6 plus 2 equals y. Negative 6 plus 2 is a negative 4. So when x is negative 3, my y value is negative 4, and that is the solution to this system. So remember, your solutions are going to be, you're either going to have 1, 2, or none. And the answers to all of your solutions are always going to be ordered pairs. Thanks.